The device wants to access a certain port in the WeChat server. Then it will carry the corresponding port number here. Then there is the application data. For example, if I write a sentence of hello here. These are two completely different types of data communication. ARP is a functional protocol that requests a MAC address. And when the device finally delivers the overall data, it will complete all the data encapsulation process. The transport layer locates applications based on ports. The exchange of visits between communications is peer-to-peer. Then for PC, received data. Applications can be differentiated through different ports. This is a port-to-port exchange. So there are some caveats you must know. First, the transport layer. It has a port number. Transport layer ports. It ranges from 0 to 65535. You will learn a lot in the future. This number you will be very common. This is the total number of ports. That is, whether we use TCP or UDP in the future. The total number of ports in our transport layer protocol is such a value. Then each port can uniquely target a service. But not every port is quite random. Not every port is strictly regulated. Instead, it is between 0 and more than 60,000 ports. Some are clearly defined. Ports from 0 to 1023 cannot be used at will. Ports 0 to 1023 are called well-known ports. It cannot be used casually. This is a port reserved in advance. For example, the local wants to initiate a service request now. So now I'm going to turn on an app service. Assuming this is a network device. I want to telnet into this device. Everyone should know. One service all over the world. If you use more, appear more frequently. That means everyone in the world. Just go online. Or when debugging the device. Often use a function. And this feature has been developed. Then make a clear rule. Reserve these port numbers. This port will be dedicated to it in the future. That is, I can name it. Then this port number. Specific to that service. Then for TCP. Although it will not be covered in detail in the NA stage. But you need to know it. It is a connection-oriented protocol. This connection is a logical connection. It is a more reliable protocol. Because it can, based on when the data is sent to the peer, you can make a confirmation to its corresponding source device. That is, by sending and confirming such a mechanism, to ensure that each message is sent to the other party. It's very reliable. There are some ports in TCP. Is what you have to remember. For example, in this picture, have a port. Everyone can see. Destination port written here is 80. If the host sends a data now, send to peer. I want to access port 80 of this device. Then now, the host is accessing the HTTP service of the peer. This service is a well-known port. Is 80. HTTP is an unencrypted web service. Then there is HTTPS corresponding to it. It is port 443. That is, if the host wants to access an encrypted web service at the peer end, then it accesses the port 443 of the peer. This is called a well-known port. Many people in the world now are using such ports. So make a clear definition. So in the future we are at the end of the NA stage. We'll also show you. I will teach you a remote management method. Telnet. This is also a TCP service. It uses port 23 in TCP. Is an unencrypted remote login. There is also an SSH. It is port 22. This is an encrypted telnet. The final data is relatively confidentiality will be stronger. So I ask you to, at this stage, to have a basic understanding of them. Because we will learn later a lot of content related to them. Okay. But in the basic course, just have a basic understanding of it. Let's take a look at the TCP encapsulation. Now when encapsulating at the source, access port 80 of the peer. If the peer I want to access is Google, I'm going to go to Google's web service. 4-layer encapsulation. Then write a 1027 locally. This is randomly generated. That is, for the source end of the current device. It is possible to generate a random port locally. Then this random port must be greater than or equal to 1024. Then locally initiated. May be greater than or equal to 1024. All the way to port 60,000. Any port between. As native device only. Differentiate between different ports. After 4 layers of encapsulation, start encapsulating 3 layers. Let's take a look at its content. I'll take a screenshot of this picture. This is the overall data access initiated by. Now the 4 layers of encapsulation are complete. To come to 3-layer encapsulation. Because source device encapsulation is from top to bottom. So let's look at the encapsulation of the IP layer. Now the source device is 1.1. The source IP is yourself. The destination IP is 172.16.10.1. 3 layers are packaged. Very simple. Then I will not fill in the other parameters. Certainly. There will be a protocol in the 3rd layer. Indicates that the upper layer is TCP. This is when data is received from that device. But today we only discuss its address and port. Some core parameters like this. Now I want to ask you a question. If after packaging, logically speaking, 3 layers of equipment installed, you know they are not on the same network segment. Now combine the ARP mentioned before. Think about it. How does host A know whether the other party is in the same network segment as it? Okay. Host A calculates with its own mask plus the IP address of the other party. Get its network segment. And compare with yourself. If it is found that the destination is now crossing the network segment, it still has to make an ARP request. But do you remember? If theoretically they are directly connected, is the same network segment, host A directly sends the ARP broadcast to request the MAC address of the peer. The peer will reply when received. But now because they cross subnets, ARP is a broadcast packet. If you still send a broadcast to request its address, this broadcast packet cannot be transmitted from the right interface through the left interface of the router. So now when host A requests the MAC address again, the MAC that is actually requesting the gateway. Now, it is time to send an ARP broadcast request to the MAC of the gateway. Please pay attention. Once involved in the host to find the gateway. Then actually intervene. The routing layer we are talking about today. That is encapsulated IP. It is found that the source IP and destination IP are not in the same network segment. The process of the host to find the gateway. In fact, it is a routing process of the machine. The realization principle of the gateway is equivalent to the host here. Wrote a root entry to go anywhere, pointing to the router. But for us, is pointing to a gateway on the host. But in fact it involves the function of routing. Data is sent to